Alright, in this video, we're going to be looking at the inductive effect, and this is an important concept to understand, especially when we move on to things like ranking acids, or ranking acid strength, rather, when we're not provided with the pKa, for instance. So, what is the inductive effect? The inductive effect has primarily to do with the important idea of stability. So, it's important in chemistry, right? All throughout chemistry, when we're thinking about the idea of stability, right? If something is stable, it is going to be unreactive. Unreactive. Whereas an unstable thing tends to be reactive. Reactive. And this has to do with, right, what something is stable, it is happy, it is in a good place, it's not going to want to change, it's not going to want to react. It's already happy where it is. It's stable. Something that is unstable, it's unhappy, it's going to want to react with something to change, to become more stable and more happy, right? They say, if it ain't broken, don't fix it type of thing. That's kind of what we're looking at here, right? If it's already stable, it's going to tend to not want to react and mess with its stability. Whereas something that is unstable is going to tend to react in order to reach at least a state that is more stable than its current one. So, keeping that in mind, what does this have to do with the inductive effect and, acid strength? So, let's just compare two acids, for example. So, let's say we have this molecule here, and we want to compare it to this one, right? Very similar. The one difference is this carbon has, instead of 3 hydrogens, it has a chlorine attached to it, 1 chlorine. So which one here is going to be more acidic? Whenever we're looking at the acidity, right, we want to first look at the conjugate base, because the stability of a conjugate base is going to be telling us a lot more about the strength of an acid than the actual structure here is going to tell us, right? So let's draw the conjugate base. The conjugate base is nothing but the original acid but without that acidic proton, right? If the acid had let go of that acidic proton, we're looking at the conjugate base. So now let's look at this one over here, right? So chlorine. So we can see that we have a negative charge on our oxygen now, right? And charges, right, whether it be negative or positive, tend to be unstable. Molecules don't like to be charged. That tends to, again, mess with their stability. So which one here is going to be more stable? Which one is going to, which then tells us which is going to be a better acid? Well, when we're looking at these two molecules, the one difference we see is the presence of this chlorine. And chlorine we know to be a very electronegative element, at least more so than a carbon would be. So this electronegative element of chlorine is going to want to pull the electron density from this negatively charged oxygen towards itself. It's pulling on this electron density. And if we do that, right, now this negative charge is going to be distributed over a larger area and with multiple atoms, right? Now this chlorine is pulling on that negative charge, and so that's going to reduce the strength of that charge. It's going to make this less negative because it's stretching that charge over a greater area, right? Whereas here, that this carbon here is not going to really be pulling on that electron density. And so the charge is primarily going to be concentrated on this oxygen, which is very unfavorable. It's unstable. Whereas this is a far more stable situation. And so this pulling of this electron density towards the more electronegative element, that is what we're talking about when we're talking about the inductive effect. So this here is the inductive effect. Inductive effect. So, well, what is this base, right? This conjugate base being more stable tell us about the strength of the acid anyway? Well, how do conjugate bases form? Conjugate bases form when the acidic proton in an acid is, pushed off, right? So, if the losing or the loss of this proton leads to a molecule that is more stable, or that is very stable, it's more likely to happen, right? If we have one that is unstable, well, the moment the hydrogen comes off, it's going to want to go right back because it's a very unstable situation. Whereas, and so that means we're not going to be very acidic, right? Because the strength of an acid is determined by its ability to release or give off protons, for instance, right? That's how strong an acid is. Goes back to the idea of pKa, is again depending on that idea of the concentration of protons in the environment. So here, if we're able to give off protons leading to a molecule that's very stable, the giving off of protons is more likely to happen, meaning this acid is going to be able to act acidically. Whereas in this case, if we're giving off this proton and we're getting something that's very unstable, we're going to want to go back to this state of having the proton, which happened to be more stable than the conjugate base, right? So if we have a weak base in this case, right, that means we have a strong acid. Whereas here, if we have a strong acid, a strong base, one that is going to want to retain a hydrogen, well, we will have a weak acid. Right? This is hopefully something you remember from Gen Chem. But anyway, because we see this electronegative element, chlorine, causing the inductive effect, it makes this conjugate base more stable, which in turn tells us that this acid is much more, or is stronger, right? So in this case, we can see that due to the inductive effect, this is going to be the stronger acid. Now, let's compare two more acids here, right? Let's say, again, very similar structure. We don't need to complicate it. Let's say let's look at the first one, right? This chlorine. But now let's say we want to compare it to this acid here. Which of these two is more acidic, right? We're kind of already jumping onto that idea of the acid strength, which is because it's the natural progression from this idea of the inductive effect. So which atom here, or which element is going to more strongly produce the inductive effect? Well, we know that fluorine is much more electronegative, right, than chlorine. So because it's more electronegative, again, if we're looking at that conjugate base, sorry. If we're looking at this conjugate base, right? Well, because fluorine is more electronegative, it's going to more strongly pull on that electron density here and much more effectively induce the inductive effect and much more effectively diminish that negative charge as compared to chlorine, which is also electronegative, just less so than our fluorine would be here. So from that, right, we can see due to the inductive effect, this is going to be our stronger acid here because the conjugate base of this acid is more stable and thus less reactive than this one. All right. Another important criteria in addition to the strength of electronegativity is going to be the distance, right, of that electronegative atom from the source or from the negative charge. So, for example, if we were looking at an acid, looking at an acid that looks something like this, where we had our electronegative element here, compared to one where, let's say, that fluorine was over here, right? Which one would be more acidic, right? Or which one is better able to induce that inductive effect? Well, obviously, if this electronegative element is closer to the negative charge, right, in the conjugate base here, there would just be a minus charge, well, it's going to be able to much more strongly pull on that electron density and thus stabilize that charge. Whereas here, the electronegative element is far too distant from this negative charge that would form in the conjugate base in order to effectively pull on that electron density and thus minimize the negative charge on this conjugate base. And so this one, because the electronegative element is closer, is able to more effectively stabilize that negative charge. So again, in addition to the electronegativity of the element, the proximity of it to the negative charge is another criteria that you must consider when looking at the inductive effect. Now, one other criteria, right? We looked at the strength of the electronegativity, we looked at the distance, and the third is the number. Let's say we have an acid that looks something like this versus one, which that's a chlorine, versus 1. So we only have 1 chlorine there versus, say, something, right, like this, for instance, right, where we have 3 chlorines, which is going to be more acidic, the acid here, and which is more effectively able to induce that inductive effect. Well, obviously, as you may guess, the one with more chlorines is going to more effectively stabilize the negative charge of the conjugate base, right? Because there's a greater force of electronegativity pulling towards this. So this charge is distributed over more elements or more atoms here, and over because there's a greater pull, that negative charge is going to much more effectively be diminished as compared to where you only have um, a single atom of that a single electronegative atom. So those are the 3 criteria, right? We're looking at the strength of the electronegative atom. So if we have 2 different atoms or 2 different elements, right? The one that is more electronegative, which is again why you need to remember your periodic trends from Gen Chem. It's very relevant even in organic chemistry. Is the one that is again more electronegative, if we're comparing 2 different atoms, is going to be the one that is more acidic. If we're looking at, for example, 2 fluorines, but one is closer versus while one is farther, the one that is closer, that's where distance comes into play, right? And now what if we have 2 that are the same proximity? It's the same element, right? We have fluorines, and they're the same proximity, but this one has 3 fluorines as compared to 1. Well, the one with 3 fluorines is going to be more electronegative. Always, it's coming back to the idea of stability and the ability to stabilize the negative charge, and that's what it comes down to here. So again, keep in mind when we're looking at acid strength, always look at the conjugate base, because that's going to give you a better idea of what's going on. And so anyway, that brings us to the end of this video on the inductive effect. I'm hoping that it made sense. If you have any questions, please leave them in the comments. If you found this video helpful, please show your support by liking and subscribing, and I'll see you in the next video.